So thank you for joining me this early in the morning, also after the icebreaker yesterday. I'm super excited to be here. My name is Stephanie, and this is in fact my first keynote at one of my favorite conferences, FOSS4GE. And I would like to share some perspectives with you today on leading with open source and driving innovation from ground to space. So you heard the official introduction. I was asked 2 days ago, why are you in open source? How did you get here, and why are you basically here? And I want to give this answer today. So I've always felt empowered by open source. I started coding when I was in a bachelor's in geography, so I was lucky that they taught Python there at the time. Then I went to New Zealand, and there I was even luckier because one of my teammates in the company I was working for was a NumPy core developer and maintainer, and he introduced me and mentored me a little bit to move towards open source. And from then on, I moved around a bit more, and I went to North America, and I was even luckier because I got a mentee position in the Google Summer of Code program back then. I started with the Python spatial analysis library, and I even got to develop my own package, and then also after further maintain and foster this package called splot in geospatial statistical visualization. So my access to coding and to open source really came from a creative, let's say, spark, from an interest a little bit in geovisualization. And then more and more, for me, the journey was realizing how powerful it is to be able to write your own tools, write your own code. And I slowly moved more into high-performance geospatial data analytics. I became a GSOC mentor on GeoPandas and also on PyCell, for example, integrating Dask or Xarray in the backends there to make the processes we had in there a bit more performant. So for me, open source also has empowered me in my scientific career back then. I got to publish all the packages I was working on in the Journal of Open Source Software, which I can highly recommend to everyone else as well, and also in other more scientific journals. So how has open source again empowered me? And I would like to bring a quote from Paul Graham from his book, Hackers and Painters. And he wrote back then, what hackers and painters have in common is that they are both makers. And again, for me, the access to coding, to open source, came from art a little bit. It came from geovisualization, then moving on to other things. But what was for me quite important was this building this understanding that we actually have this really creative power of knowing how to code and doing and writing the tools we really need. So the second major thing that I think has really empowered me in this journey was the community. In my case, a little bit the NumPy and the PyCell community. So I've always experienced much support and encouragement. Also, I have to mention Sergio Ray here, who was the person who really built the PyCell community, and it is to date one of the most, let's say, diverse and inclusive communities I have ever known. So if you want to talk about inclusiveness and diversities in your communities, I can highly recommend reaching out to Sergio Ray. I'm sure he would be super happy to share some thoughts on how he did it and how he works with the community here. So open source has empowered me also in a way to work where I work right now, at the European Space Agency. And for the rest of the talk today, I'm hoping to give that back and maybe empower you a bit to join me in the journey of Earth observation and the journey of space, and also in your own journeys. So what is the European Space Agency? We are around 5,500 people working across and with 22 different member states. and we say that we make space for Europe. So what does this mean? Mainly, what we're doing is we're promoting cooperation amongst these participating states in research, in technology, but also in commercialization and application, always for exclusively peaceful purposes. And roughly everyone that lives in Europe or in our member states pays around about 10 euros per year to keep, let's say, all the satellites working and also space happening for ESA. So I'm from ESA Earth Observation, and ESA Earth Observation vision is taking the pulse of our planet. I'm sure some of you have heard that before, but how are we actually doing this? We have a total of 79 different missions, either heritage, in development, operational, or in preparation. And generally, we separate these missions into 3 different lines. So we have here on the left side the science missions that are ESA missions, the Earth Explorer missions. And these science missions are usually or are purposefully novel instruments we fly. They usually have, not usually, they always have a big scientific question or a big Earth system science questions they are trying to answer. And they're highly, let's say, innovative R&D missions. Then we have our Copernicus missions in collaboration with the European Union that are more operational. So we count the Sentinels here. We also in future count the Sentinel expansion and next generation missions. And last but not least, we're collaborating with EUMETSAT on a set of operational meteorology missions. And today, what I would like to do, I'm also a bit biased because I worked for 2 years on the biomass mission. I would like to take you on both a personal mission of open source and following the biomass mission from its origin to its launch and potentially also to its final stages. So, like I said, Earth Explorers are highly novel R&D missions that usually have a science question at their basis that needs answering. So what I brought here is a little introduction to, no, sorry, okay, other slide. So first, so today we are going from phase 0 to phase F. So this is genuinely the mission life cycle, how we describe it at ESA, how we plan the missions, and we're going to basically walk the biomass mission through phase 0 to phase F today. Starting with phase 0 and with an introduction to biomass. So you may have noticed it was planned to launch in 2023. I can confirm it is not launched yet. At the moment, the planned launch date is 2025, so next year. And going back to our mission phase 0, you may have noticed in this video that generally there is 3 elements we look at when planning such an Earth Explorer mission. And the first one is, in fact, that there is an important societal and also Earth system science question to answer and to contribute to with our Earth Explorer missions. In this case, quantifying better the land carbon exchanges and how much carbon is stored in tropical rainforests, mainly. So the second thing, or maybe the first thing, is that you may have also noticed this video was not just from ESA. It was actually mainly from the University of Sheffield that is, in fact, the leader of this mission. So all of our Earth Explorer missions, they are not decided by us, really top-down, but they are always proposed and pushed bottom-up. And there's always a big, large community that stands behind it, that includes scientists, that includes engineers, that are forming before they hand in this mission to basically say, hey, this is what we need. So these are always bottom-up missions. And then the third element is, of course, that asking these questions often comes with technology maybe that we don't have yet. So in this case, having this question and having the community that has a knowledge about how we may be able to answer this question, we have an iterative process between the technologies at play, how to best answer these science questions, and the different elements of participants that they bring on the table. So in a way, I found that sounded quite similar to the beginnings of open source software projects. So in the end, either we're individuals or we are groups that need something, usually. So that have a concrete need for a certain type of development. So then usually what do? We go out, we discuss with our communities, maybe we move forward as individuals, but also very often we move forward as a group. And we look for new technologies and solutions to start or maybe contribute to as coders to open source software projects. So the point I want to make here is that from where I stand today and what I have seen is that most innovation is really bottom up. And I can repeat again that we as an open source community, what we have in common with hackers and painters, and in this case also Earth Explorer, Earth observation missions, is that we are all makers. And this is quite important for me, also for you to take away. There was a question 2 days ago also, but what can we do bottom up? There's actually so much you can do bottom up, and most of the things I have seen are actually coming from bottom up. So the other thing I want to stress here, as this is a talk about leadership with open source, is that, as John Quincy Adams says, if your actions inspire others to dream more, learn more, do more, and become more, you are a leader. And I think that's also something we are very good at with open source. We're usually a community that is really basically believes in what they do and stand behind what they do, and I think we also have a lot of capacity and capability to inspire others with this. So what both Earth Explorer missions, hackers and painters, have in common here is think that they're leaders. They follow their instincts, they focus on getting the right things done, we all side with risk in a way, and we focus on articulating tomorrow. So this is fantastic as a vision. Now we're moving towards the implementation phase. So for the biomass mission, this means from the first definition, we're going to more stages of feasibility studies, preliminary definitions, and then more detailed definitions. So, and since we're at a open source software conference, going forward in this talk, I will not focus on the hardware of the biomass mission, but purely on the software, on something that we call processor development. So, as a little explanation, processes are more or less like is the operational software, the code that translates our raw radar data into maps of forest height, forest disturbance, and above ground biomass in the case of biomass. And this process, roughly from the beginning of a mission to the actual launch, can take, in fact, up to 20 years. More dependent on hardware than on software in this sense. So the problem we're often facing when we start developing these processes, these algorithms, this code, is that in fact we don't have data we can work with yet. Of course we can fly and we can collect, let's say, sample data sets. Of course we can simulate some data sets, but as we don't have an operating mission, usually there is no real data we can work with at this point in time. So what we usually then hope for and think is as soon as the mission is in orbit and we collect real data, we can very rapidly improve our processes that have gone through an initial definition and operations phase. And also, as Earth Explorer missions are usually planned for a shorter period of time, roughly around 4 to 5 years. We need to demonstrate relatively fast in our terms that the mission goals can be achieved, that the science questions can be answered. So what we want is a community formation as fast as possible, ideally even before the launch of the mission and before this data becomes available. So one thought we had a couple years ago was, well, we always, as an institution, provide open data products. But is there benefit to actually complement these open data products with open source software projects? We said, okay, we will try this, and we initiated a small, let's say, experimental development called BioPal. It's the Biomass Product Algorithm Laboratory. It's an open source software project with the official biomass algorithms in Python, and it was the first time ever that we did release and make official processing algorithms publicly available. So why did we do this? Because in a way we started realizing the benefits that the way of working in open source that could also bring to our processing algorithms. Being there as soon as the data becomes available, we already hopefully have a community, and they have access to both data and the code, so they can, as a scientific community, fastly improve upon the first definition of the processes. And we also go here, in this case, from open source algorithms, so from the first definition of the processes to open source software projects. So we move from the algorithmic side to more the operational side, which in the language of open source software programming, we would probably call long-term maintenance. So we also started with Git and version control, of course with an open license and an open repository. And then it started to be, let's say, fairly novel for us at ESA. We started also thinking more about, okay, best coding principles, documentation, not only for us, but for others to join the project. We started thinking about reproducible environments. So in this case, We were lucky because there was a parallel project called the Multi-Mission Algorithm and Analysis Platform we could make use of. We looked at packaging and distribution, continuous integration and testing. And finally, we also started to realize that we started to need things like governance structures. We needed to do more active outreach to really arrive at the stage where we can do more balanced improvement and maintenance, or more fast and more innovative improvement and maintenance. So the question now is, was it a success? We always talk about institutions maybe aiding open source more. So the takeaway I think we had from this very small project was that we really needed the support from both bottom-up and top-down. What top-down can do is, let's say, create the possibilities for others to do open source, but I don't think it would ever work if top-down just more or less like says everyone has to do open source. Because then, in my experience, the understanding would be, okay, we put an open license on it, but we all know there's so much more to open source than just an open license. So the main takeaway here was that it's really important to also have somebody from the community, from bottom up, that really wants to push and lead a project like this. So another important takeaway from this experience I would like to share today is the concept of inner source. So the inner source commons were founded, I think, 2015, have been around for a while, and inner source is the use of open source best practices for software development within the confines of an organization. And I think that gives us, also as open source software developers, a lot of action potential and a lot of power, because what happened with Biopal was we started closed-sourced, working with open source principles on these processors, and then all of a sudden the step to actually making them open wasn't really that far anymore. And everyone was quite excited about the way of working in general. So maybe this is a takeaway for you working maybe in non-open source companies, that there is small things that we can introduce that may help the uptake and also the awareness of open source in closed source institutions. So, and another takeaway was that, again, open source is a bit more than code and software, and also it's more than the license. There is management tasks that really aid these projects, that are drawing up the governance structure, drawing up organizational management, and also community management. And I was wondering a bit, also thinking about myself and how I used to do open source, maybe that's a little bit of a skills blind spot for us sometimes. Because we really, and I'm talking purely with open scientific Python glasses on right now, we really like to code and meet for the code and for the software, but sometimes there's other stuff that has to be done, like planning meetings, there's a certain type of and sense of leadership that has to be in the organization, we have to decide what type of governance model we want, we need somebody who understands licensing and IPR, and we need maybe communication and outreach, and in a way, sometimes also diplomacy to us as a community, but also to the communities outward. So the last takeaway here is a little bit just to spark a discussion. Also talking about the diversity topic, there is skills other than coding that we need in our communities. And sometimes the question is, how could we, for example, foster them a little bit more and a little bit differently? Okay, so moving on from phase A, B, and C to phase D, the qualification and production period before the launch. And I like to call phase D also D like danger zone, because for us, at least in biomass now, industry players come on board, and first conflicts maybe between the ideologies of open and closed arise. But also, I think D is a zone that opens up debate for us. I'm not going to go into this with detail because I think we had great conversations yesterday, and there's many more, let's say, keynotes, for example, from Paul Ramsey that look at this in detail. But we know that there is potential to do business with open source, be it with consulting. I think QGIS and others are a good example for this, be it through packaging and distribution, for example, what Red Hat did and is doing, being through cloud distribution and infrastructure co-development, like Coiled does with many Dask contributors, or being it through dual licenses and premium features, like, for example, GitHub does. This is by no means a conclusive list, but just to put it out there, we know some people have managed to make business with open source. And sometimes, what I've also asked myself, maybe what the conversation sometimes brings in this debate is, are institutions our saviors? Wouldn't it be so great if people like institutions like ESA or the EU would pay for long-term maintenance, right? So to spark the debate here, I would like to bring a couple of considerations that I call European self-help open source considerations, because we looked at it from the ESA side, and one of the major, let's say, deal breakers we found out from our side is, in ESA, we can't move funds outside of our member states. And there was no opportunity for us to even think about supporting open source more, because we could not easily identify, a larger institution, a larger communal a body that would allow us to move funds to them. So I know now that that is under work, but this is definitely a consideration. Like, sometimes we are individuals coding at a project, but we are missing the structures, sometimes as open source projects, to really function in an economic system. And this is something to think about, at least. So then the next consideration was, which project should actually be funded? Do you really want that decision to be with the EU or the UN or ESA? I'm not so sure. So that's another thing, like, as a community, I think that is something we should be able to internally discuss somehow. And then the last thing is, what actually happens to an ecosystem that is built without money, and then suddenly you introduce money into the system? It's nothing I can answer, but I think it's certainly something we should consider when we talk about, introducing these type of concepts into our communities. So the question here also from my side is, what is next? And I think Atina also really beautifully described it yesterday. If we want to go far, we need to go together. And these are just two institutions or bodies. I think there's more than those. But just to put it out there is a reason for the existence, also from, let's say, an ESA, an EU, an institutional perspective where I work at, that these exist. And maybe it's worth exploring these type of concepts a bit more as a community at home. Okay, but so now we have successfully entered, we've navigated all the dangers, and we have successfully entered the launch and commissioning phase. So this is a really nice example of a launch with a Falcon 9 rocket. I just think it's a very cool video, so I wanted to show it, from the recent EarthCare launch. And maybe what it also displays is when we launch something, also at ESA, it's usually a moment of celebration. It's a very exciting moment. We have worked so many years for making this moment happen. And I also want to remind you as an open source community what we have achieved already. Like there is companies that can do open source. There is open source projects that have vastly innovated globally. So I think we can also take this moment a little bit to celebrate what we have achieved already till date. Yeah. Definitely. Yeah. So, moving on from celebrations, there's always more work, we know, it's called long-term maintenance, into the operational phase, also of our biomass mission. And also here in the operational phase, as an Earth Explorer mission, we have to ask the question, is it successful? And the way how to demonstrate for us and to know for us at ESA that a mission was successful is that we can demonstrate that this mission has contributed to answering the science questions we have laid out at the start. So in terms of biomass, if we can demonstrate that it does in fact contribute to more major political questions, science-informing questions, then it is a first success for us. And we have been successful doing this with other missions and also other programs, for example, the Climate Change Initiative at ESA. And we know that from space, in terms of monitoring, the evidence of climate change, for example, is compelling. We know that we can help informing, bending the curve in a way, also through informing the global stocktake or informing bodies like the IPCC with our data. So now, as ESA, we often ask the question, yes, but, so what comes next? And I think that is very much also driven by this knowledge that we have so much data around nowadays, not only from Earth explorers, from Copernicus missions, from meteorological missions, from new space, but also geographic data. And we think that it is also time to foster it a bit more, leveraging these 50 years of public and private investment in space. And now kind of like comes a bit the part where I want to show you how we do that. So how we more or less like try and build what comes next after this initial, let's say, solution of the scientific question. And I hope that maybe that is also something that we as an open source community can look at. So in this sense, we know that space plays a significant role, but we also know it's still far beyond the strategic and societal potential. Okay, there was a video. Sorry, it's not running. But the takeaway here is that we also know that Earth observation is not, Earth observation data is not a own standing. It has much more value, or like the value is enhanced if we can combine it with other data sets, with other data sources. And this is a geospatial conference. So here also comes a little bit the information piece that, in fact, the more data, of course, we can combine, the maybe more intelligent of a service we can develop and we can provide. So I think there's a lot of value in working at these intersections. For example, Earth observation and geospatial data, raster and vector files. So how do we do this? How do we, let's say, enhance or try to enhance and approach connecting maybe to other communities, finding out how we can accelerate also the green transition and how we can accelerate using space in the green transition. So there's a very new initiative called the Space for Green Future Accelerator. I'm not going to go into it in detail, but what I would like to point out here is that one of the things we did do in this initiative is we went out as a body, an institution, and we're starting to really build strategic partnerships with other green actors. So we are looking for others that have the same interests we have, and we see how we can align our resources, our efforts better. So in this case, for example, with DG Klima, with Copa-Cogeca, WWF is also part of it, with the CEO of Water Mandate, with the European Maritime Surveillance Agency, and others. And also what we did here as well, because we know that sometimes we don't just want this to be an ESA initiative, we actually want this to be an open collaboration with partners. So we're also going out, and we are most likely founding a non-profit, independent, co-governed and mission-driven body with a legal framework that is super light, effective, flexible, and efficient, because we all basically hate overhead, like no question. So how do I translate this to open source at the moment? So the question again, what comes next for open source? So, and thank you, Kodrina, for introducing me to this fantastic slide, and also Paul Ramsey for writing these reports for a while. So we know that the open source geospatial ecosystem is a mature ecosystem, but we also know that we have these tribes. So Paul Ramsey back then described it as the C tribe, the Web Wildcard, the Java tribe, a couple others. I think that can also be extended towards, now we have the Python tribe, we have the R tribe, we have the Julia tribe that also kind of comes in. So we have all of these fairly loosely connected communities at the moment. And coming back to the European self-help open source considerations, is there a way how we as communities can represent our interests better? Maybe. Is there a way how we could align our resources better? Is there a way how we could support each other better? And again, I think if we want to go far, Atina said it, we need to go together. There is existing institutions like OSGeo and like, for example, also something that allows this conference to be here and allows us to talk to each other. But is there something more we could do and we could form to really, let's say, stand for our interests and extend our working together? So coming towards the end of life of the biomass mission. So when a mission is decommissioned and it was successful, the cool thing about it, it doesn't just disappear, it transforms. So in the case of Earth observation, Earth Explorer missions, for example, we have examples like ENVISAT that transformed to Sentinel-1A, or METOP second generation missions. We have examples like AEOLOS that went to AEOLOS-2, an operational meteorology mission. We have examples like Cryosat that will be represented in Crystal, now a Copernicus mission. So basically drawing the conclusion here for the open source community is that the genius of our way of working, really, and the genius of open source, so David Eves said, is to be able to break projects into chunks where people can go work in smaller groups and individuals, and then they come back together and they bring it all together into one project. And we do that really well on, let's say, the individual project basis. But maybe this is also something, because we know how to form communities well, we could do even better on the broader ecosystem basis. So again, I hope to conclude this talk that now also you feel empowered by open source. Or maybe you feel empowered by the biomass mission, hopefully both. I would like to remind you that we're all makers. We're hackers, we're painters, and we are Earth observation mission scientists. We have the creative power to, from the bottom up, make a difference and really push something forward. I would like to remind you on also the benefits of small steps, and for example, thinking about concepts like inner source, like not just going for, basically closed or open or nothing, but maybe starting in companies in closed source environments to just slowly drop the feeling for the open source vibe a little bit. I'd like to recap again that we are fantastic at community building, that we really know how to do these things well, and that we know how to do these things well in smaller communities, also in larger communities. But maybe there is a way how we can, as an entire ecosystem, represent our needs and our thoughts better. But like danger zone, like debate zone, this is something I think that may start a conversation, and by no means and maybe somebody has comments and thoughts on this already. So with this, I say thank you for sharing this morning with me. I'm still around for questions for the next 2 days, and I'm looking forward to listening to the rest of all the interesting contributions and talks today.
Thank you. We have time for one very quick question. Okay, you got it.
Thanks so much, Stephanie. That was an amazing presentation. So my question goes about how biomass will be doing a partnership or being complementary to the NICFI project right now running by the Norwegian Space Agency and using data from Planet and also from Airbus. Is there any thought about how it will be complementing each other, or it will be a separate effort?
So at the moment, we are working quite closely with the NISAR and JEDI missions. I think that is just simply because we know those communities well. Complementarities, I'm sure there will be, and that's why we need this community formation fairly quick before the launch of the mission. But I haven't been in the team for 2 years, so by now I'm not quite sure. I don't have the overview. But if you'd like to, I can connect you to the right people.